Hi guys, welcome back to my YouTube channel Study with Shakira. So today we'll be reviewing AP Statistics Unit 9. So regression inference. So it's when we use data from a sample to make conclusions about the true relationship between two variables in the population. So an LSRL, the least square regression line, is given by this formula, which we reviewed before. And the y-hats are predicted y, a is a y-intercept, and b is a slope. So for the b interpretation, for every 1 unit increase in x, y is predicted to increase or decrease by blank on average. The a interpretation is when x equals 0, the predicted value of y is blank. So usually we're given a table like this. All that really matters is that we know that the coefficient, the constant, that area is the y-intercept. Where we see 0.744, that's the y-intercept. And essentially everything on the bottom row is important as well. 0.497, that's where the slope is, which is also important, which is b. And then we go to the bottom row right next to it, which is the standard error of the slope, which is 0.037 in this context, for example, which is important. And then next to it, where we see 13.610, is the t-value, the t-score. And then right next to it is the p-value, 0.000. So we're literally given everything often when we get this type of table. And given also is the population symbols and the sample statistic symbols. So remember for correlation as well that it's always negative 1 to 1, with negative 1 and 1 being the strongest and 0 being weak. R squared is usually interpreted by blank percent of the variation, and y is explained by the linear relationship with x. S, the standard deviation of residuals, is usually interpreted by the predicted values are typically off by about blank units. So residuals, which is y, the actual value, minus y hat, the predicted values. So a positive residual is an underestimate, meaning that the y value, the actual value, is greater than the predicted y value. And a negative residual is the overestimate, which basically means the actual value is less than the predicted y value. A residuals plot is where we graph all the residuals. The x-axis is the explanatory variable x, and the y-axis are the residuals. We want a random scattered graph around 0. We don't want a curved pattern because the relationship is not linear then. A sideways Christmas tree, which basically means a non-constant variance. In clusters, that means something is weird in the data. So regression inference. So the conditions for it are this. L for linear. So the scatter plot looks linear. The residual plot is random, like this, it's randomly scattered. I for independence. Data is collected randomly, the 2% condition. And for normal, residuals look pretty normal. The histogram sounds like a normal plot. And E for equal variance. The residual plot has a constant spread, no funnel or like the sideways Christmas tree. So look at this problem. Which one is the best graph, the best residual? Well, hopefully you said C because it looks really randomized and around 0. We see that A, B, they have like a shape, and E and D are like a sideways Christmas tree. So E and D doesn't have a constant variance, and A and B just have like a pattern. It's not linear. So now we'll be looking at regression inference for an interval. So this is called the t-interval for the slope of a regression line. So first is our general formula given on the reference table, and then the specific formula. And we use a t-distribution because we don't know the actual standard deviation. We're choosing S. And the df, the degrees of freedom, is n, the sample size, minus 2 now. And we interpret this by we are blank percent confidence that for every 1 unit increase in x, the mean response y changes by between blank and blank. And basically, I'm not going to go over every single step because it's essentially the same thing over and over again as unit 6 and 7. So basically, we always state the variables, then we name the procedure, and then we check conditions, we state the parameter, the general formula, the specific formula, calculate it, plug in the values, we interpret it, and then we just say if it's significant or not. And I say optional because it depends on if the question asks for it. Regression inference for a test. So the hypothesis is B, which is the population. So for slope is equal to 0 for the null hypothesis, which is indicating that there's no relationship. For the alternative, we're saying that the slope is either not equal to, greater than, or equal to 0. It's basically saying that there is a relationship. And it's called the t-test for the slope of a regression line. And this is the general formula given on the reference table, the specific formula, and then we interpret this by because our p-value is greater than or less than our a-value, we reject or fail to reject the null. There's insufficient/sufficient evidence of a linear relationship between x and y. In context, of course. I'm not going very in-depth because it's pretty repetitive again, like in unit 6 and 7. And again, it's a t-distribution, and the degrees of freedom is n minus 2. And these are all the steps. Again, I'm not going very in-depth, but we always have to state the variables, name the procedure, check conditions, state hypotheses, general formula, specific formula, calculate, plug in the values, find the p-value, and conclude. And we only interpret the slope if it's asked specifically. Also, if we go to the number calculator, we can always double check our work for test or interval. For example, if we go all the way down for slope, if we plug in all the values and keep going, it'll give us the result. Only use this to double check your work because you still have to show all your work for specific answer.
Like and subscribe, please. Bye.